Welcome to lecture 6. This is part 1. What I'm going to suggest you do to watch this lecture is the following. Open up your Nimitz file. And if you don't have your own, I have posted one for you to download. It's just a blank Nimitz, and it will be useful for you to start from there. And then as you're watching this video, follow along and add the objects and modify the Nimitz model in the same way I'm doing it. I think what I've noticed from the last modeling exercise that we did in class, which was this past week when we were doing the DMV, is that I think some of you have been watching the video, but you weren't really clear on some of what I meant about the changes to Simio. In particular, I noticed that some of you were struggling with adding in like the controls and the responses and stuff. And that's fine. I mean, it is a new tool and a kind of a different tool than say R or MATLAB or any of the other coding languages, Python, that we use. So it's good for you to get the experience to maximize the utility of this lecture. Okay. So today, and in this first part, we're going to talk about initialization and how to change our models so we can have more complicated versions of initializations. Okay, so we assume in this model, remember, that midshipmen are arriving to the Nimitz bar with an exponential inter-arrival time with a mean of 41 seconds, which is, of course, the same as saying that it's a Poisson process for midshipmen with a rate of 1/41 seconds. And then what if we wanted to model the following, that when it initially opens, the number of midshipmen waiting follows a discrete distribution. In other words, these are the probabilities that when it opens, there's already some midshipmen there waiting, okay? So we're going to use two source objects to model this, and we're going to have one source that's just going to be for this distribution here, okay? And then the other source is going to be the standard source that we already had there, okay? So the first thing we want to do is we take our model, and you're going to notice in the model that I posted that I've already added connectors, okay? And these connectors help. You don't need them when you have a really simple model, but at this point, we should start using them all the time. So you take the connector over, you click on it, and it'll let you put a plus at the start and at the end. And you keep doing that, okay? So you're going to have 3 connectors, and we're going to actually need them when we start doing more complicated things that we're going to do in this lecture. Okay, so if that's confusing to you, please come and talk to me about how to add them. It is just a matter of clicking on connector, and then you start them at the blue dot for the object, and click then on the gray dot for the place where you want to connect it to. And what you'll notice when you do that is when you move the objects around, the connectors actually are sticky, so they'll stay. Anyway, if you open up my model, you'll see something that looks quite a bit like this. And we're going to need to add another source object. So we already have one for the ordinary mids. And we drag one out, and you should rename it so it looks like this. It has initial arrivals as the name. Okay, so that's just clicking in that field and typing initial arrivals. Okay, and now we want to, remember over here is the properties. Okay, so once you click over here, this is the properties menu. So that properties menu, when you look at it for the mid arrival, now remember this is the old arrivals. So over here, what we've highlighted is this guy here, and we see that has mid arrival. Okay, you see that it has an inter-arrival time of 0 and a random exponential. Okay, so and it has a time offset of 0. Okay, what that means is that the first arrival is going to happen right immediately. Okay, so in essence, you think of it this way: a simulation, if you didn't have anything else going on, why would you start the simulation clock before the arrival gets there? Okay, if that's all you're worried about. So that's not ideal though, because remember, we're gonna want to offset that time because we want the initial weighting midshipman to look like this discrete distribution. So what we do is we're going to make the time offset be identical to the inter-arrival time, which means that before the first arrival, there's a wait time. So you can think of this time offset, this is sort of the initial wait time. And if you think about it, you can actually model quite a few interesting initial effects with that, because that doesn't have to follow the same distribution as the inter-arrival time. It happens to, and we want it to in this case, because we don't want to start this arrival process until after sort of the clock has been started. Okay, and this is how you can do that within Simio. Okay, cool. So now we go over to the initial arrivals, and so back in that picture, you should select initial arrivals. So you select that, and again, you look over at this property window on the far right, and you see it has all the default settings. So we're going to have to change that. Okay, so the first thing we do is we think about this inter-arrival time. Now, what do we want to do with this inter-arrival time? We want to make it so after the initial, there's no more arrivals after initial discrete distribution. All right. So what do? Well, we change that, and we're going to change it so that instead of being a random time, we're just going to make it infinity. So you literally select all that thing and then type in capital I and infinity. Okay, so make sure you have a capital I and the rest lowercase. But yes, so this means that there'll be no more arrivals, right? Because it obviously, if the inter-arrival time is infinity, no more arrivals ever occur. Okay, and this is because, remember, this is the initial arrival process. So, okay, cool. Now, how do we model that initial burst? If we just left it as is, there would only be one entity per arrival. We don't want that. We want it to be this discrete distribution. So we're going to select that and change it into a discrete distribution. And the command to do that is random.discrete, where v1 is the ith value that the random variable can take. So, and then this is the cumulative probabilities. So we're going to want, so for example, if we wanted, if we wrote 1.1, 2.3, 3, 1, this would say 10% of 1. This is cumulative, so this says 20% of 2. And this says 70% of 3. And of course, now we're going to want to change this so it looks like what our actual distribution was. And if you recall, it's going to have to look something like this. So this says 20% chance of 0. This says that there's a 50% chance of 1. And then this says there's a 15% chance of 2, a 10% chance of 3, and finally a 5% chance of 4. Okay. If that's confusing to you, please do ask me, send me questions, right? Because this is because of the nature of having a cumulative probability. Okay, so now once you've done that, go ahead and run your model. Okay, and you should get something that looks like the following. So when you click on the Results tab, so after you run the model, remember you're going to have to change the multiplier. Well, actually, the multiplier might be changed on yours. Anyway, run it. If you want to change the multiplier to speed it up, that's fine. Do whatever you want to do there. It depends on if you're using mine or if you're using yours for what you may or may not need to do. You can click on the results, and then you can actually scroll all the way down in the results to the source, and you're going to see there's the initial arrivals and the mid-arrival, and you can see that most of the arrivals come from the mid-arrival, which is as it should be. So there were 726 mid-arrivals. For my results, I actually got one arrival. So, and this occurs with 0.5 probability before, and of course, now that we've done it, we know it happened in my simulation. And of course, you should see a number here that's 0, 1, 2, 3, 4, or 4, right? Because remember, that was the only possibilities. If you see anything but 0, 1, 2, 3, or 4, you know that you did something wrong in that discrete distribution. Anyway, but right. So for me, I got the most likely outcome, which was actually 1.